Okay, in this page we'll look at a new example, but kind of expand on the same ideas we were looking at. For example, will it be a boy or a girl? A pregnant woman often opts to have an ultrasound to predict the sex of her baby. Assume the following facts are known. Fact 1, 48% of the babies born are female. Fact 2, the proportion of girls correctly identified is 9 out of 10. Fact 3, the proportion of boys correctly identified is 3 out of 4. Oh, that's not great. Okay, so that's not great. Oh, wow. Okay. I think now this study was, or whatever, this thing was probably done before. I think nowadays, I had it with my son. They have a way to take a blood sample and test male or female DNA within your blood sample. It's freaking amazing. Anyway, so this was probably before when the ultrasounds were done. Literally, the doctor was just trying to look at the ultrasound and see what the genitals look like of the baby. That was literally it. That's all they did. That's why the proportion of boys correctly identified is 3 out of 4. That's not great, but that's because it's not very scientific, you know? I mean, I don't know. That's kind of funny. Anyway, here are the questions we want to answer. Question 1. If the examination predicts a girl, how likely is it that the baby will be a girl? So that's going to be a conditional probability. What is the probability that the baby is a girl given that the examination predicts a girl? You know, we'll kind of get into that more, but just keeping in mind that the way they phrased it, it sounds conditional. Question 2, if the examination predicts a boy, another conditional, how likely is it that the baby will be a boy? Maybe now that it's kind of in our minds, we'll write that down. Well, in my mind anyway. The top one, probability that you're going to have a girl, given that, so that's the vertical bar, not an L, given that exam predicted girl. I'm trying to write, sorry. Yeah, and then the same thing for the boy one. Probability of boy. What's the probability that it's actually a boy, given that it was predicted to be a boy by the exam? Exam predicted boy. Sorry, I'm not writing very well. So let's consider what the possibilities are. It could be that the ultrasound examination predicts a girl, and either A, a girl is born, or B, a boy is born. Anyway, they looked at the ultrasound. Maybe sometimes I think the baby's moving around a lot and they can't see things very well. Something like that happened and it was actually a boy when they thought it was a girl. Or the ultrasound exam predicts a boy and either it's actually a girl or they were correct and it was a boy. Those are the I guess that's like 4 possible outcomes, right? 2 here. A girl is predicted and a girl's born. That's one option. A girl's predicted and a boy is born. That's a second option. And then a boy is predicted and a girl is born. That's a third option. A boy is predicted and a boy is born. So there's 4 things that could possibly happen when there's an ultrasound given, or what they say, an ultrasound exam. Anyway, let's represent these 4 possible outcomes in a two-way table. On the left we have the categorical variable prediction, and on the top of the category we have the sex of the baby. Notice that this table is not filled in yet. It's just kind of written out just so we have it ready. This would be how you'd make your own if you wanted to. Just get ready to put some numbers in there, you know. Now we find ourselves in an interesting situation, the two-way table without data. The key idea is to create a two-way table consistent with the stated facts, then use the table to answer our questions. Okay, let's see if we can scroll down a little and look at this. To get started, let's assume that we have ultrasound predictions for 1,000 random babies. We could have picked any number here, but 1,000 will make our calculations easier to keep track of. So starting with this number, just because it's a nice round number, 1,000. You know, it's a multiple of 10, multiple of 100, so percentage will be kind of easy. Starting with this number, we work backwards with our 3 facts to fill in this hypothetical table. The first step is to put 1,000 as the overall total. So I see here, yeah, the raw totals and the column totals. So the numbers that are above that number 1,000 will be how many total boys and then how many total girls. So let's consider fact 1. 48% of babies born are female. So it might have been more convenient to make this total out of 100 instead of 1,000, but whatever. Since 48% of babies are born female, let's see, if you remember that means 48 of every 100 babies are female. Then we can think about that as, now we're talking about out of a total of 1,000, not out of 100. So if I move from 100 to 1,000, that's me multiplying by 10, right? Times 10. So I'd do the same thing here. Times 10, 48 out of 100, that means 480 out of 1,000. So I'm going to put 480 are girls. Raw totals, yeah. 480. I'm sorry. At first I put 480 here, but that's for the row where the test predicted a girl. But we're not talking about whether the test predicted a girl or not. So I think we don't want to put it there. And I'm actually going to scroll down because there's a bigger table down here that will make it easier to see. This table, the little cells are very small. So we put 480 here. Like they said, 48 times 10, I guess, is 480. 48% means that, yeah, 480 are girls, okay. 52% are boys. And we get that. They didn't tell us that, but just a baby's either born a male or female in this study anyway. If 48% are girls, then 100 minus 48 is 52. The rest must be boys. So 52 times 10 is 520. That's what they put here. That's the total number of boys born. Let's see, and these are marginal totals, as it says here, because this has nothing to do with the explanatory variable, whether it was predicted to be a girl or a boy. We haven't even talked about predictions yet. You can check your work. These numbers should add to 1,000. 480 and 520. If we add all the girls and boys together, we get the total number of babies. Now let's move on to fact 2. The proportion of girls correctly identified is 9 out of 10. Okay, 9 out of 10 is 90%. So, yeah, you just multiply by 10. 9 out of 10. Yeah, 9 of 10. If we want it as a percentage, we'd like it to be out of 100%. How do I get from here to here? 10 to 100, I multiply by 10. So I do the same thing here. 9 times 10 is 90. That's where they got the 90%. 9 out of 10 is 90%. 90% of the girls are correctly identified. So what they want to know now, let me see here. 90% of the 480 girls are correctly predicted. So they want to know what is that? What's 90% of 480? To find a percentage of something like 90%, we move the decimal over until it's a decimal number, so 0.9, and multiply by the number you're looking for, the percentage of. So instead of 90% of 480, I'm going to ask what's 0.9 times multiplied by 480, and they got 432. So if we do that calculation, so that's 90% of the girls that are correctly identified to be a girl. So of these 480 girls, 432 of them were predicted to be a girl and actually were a girl. So what's left of, I guess, this number should be what's left. There were 480 total babies born, in this example anyway. 432 of them were correctly predicted to be a girl. How many were predicted to be a boy accidentally? Well, you're either predicted to be a girl or you're predicted to be a boy. So it looks like 48 is the difference there. So I'd put 48 in this place. Yeah, because it should be that this bottom number, the marginal total, 480, should be the two numbers above it's added together. Okay, so let's see then. 10% of the girls are, or you could have done it that way. Yeah, sorry. You could have done, what's 10%? Because if 90% are identified to be correctly identified, what's 100 minus 90? 10% of the girls must not be identified correctly. And then you just find 10% of the total girls. 10% of 480 is 48. Either way, you should get the right answer. So we'll fill those values in the table for sure down here. So they've done it, by typing it, but we were writing it. That's fine. Okay, now we'll focus on the boys, or the babies that were born boys. Let's see. So finally, we use fact 3. The proportion of boys correctly identified is 3 out of 4. We already had this number because we said 480 is the number of babies that were born female. The difference between 480 and 1,000 is 520. Okay, 3 out of 4 boys is correctly are correctly identified. That's 75%. 3 out of 4 is 75%. And that, if you're not sure about how do people come up with that, 3 out of 4 is what percent? I always think the total number here is 4. 3 out of 4. I want that to be out of 100 because then I can talk about percentages. What do you multiply 4 by to get 100? It's 25. You can just divide it. What's 4 into 100? It's 25. So I need to do the same thing over here to get my correct number. 3 times 25 is 75. Anyway, that's kind of a simpler example, but for more complicated ones, that should work. 3 out of 4. is the same as 75 out of 100. So we're talking about 75% of the boys are correctly identified. So we kind of do a similar calculation to before. What's 75% of the total number of boys, 520? 0.75, the decimal form of 75%, times 520 is 390. So we'll put that, those are the correctly identified. So they were the ones that were predicted to be a boy. So we got 390 here. The only thing we haven't really filled in is how many were predicted to be a girl but were actually boys. So if 75% were correctly identified, that means what's left over, 25%, which is 100 minus 75. 25% of the boys are misidentified. So you can get that number by subtracting these two. 520 is the total number of boys born, minus there were 390 that were correctly identified. That means how many were there that were incorrectly identified? Is that 130 if you subtract those? I think so, 130. Okay. Yeah, that's what they got here. Okay. Fill in these values in the table. You can check your work. These numbers should add up to the total number of boys. The boys who are correctly identified as boys plus the boys that are misidentified as girls should be the total number of boys when you add them together. Filling in the row totals, we now have a complete hypothetical two-way table based on our given information. So they got those final values, these guys, 562, just by adding the two numbers next to them. This 432 that were correctly identified as girls, and then the 130 that were misidentified as girls but were actually boys. Those two added together should be this total. And then same thing below, they got this 438 total should be those that were predicted boys but were actually girls. There were 48 of them, plus the number of boys that were correctly identified as boys. Those are 390. They add those together, you get to 438. We're now in a position to answer our two questions. First, if the examination predicts a girl, how likely is it that the baby will be a girl? Answer. We are asked to find the probability of a girl given that the examination predicts a girl. This is a conditional probability like we wrote above. What's the probability? This is how they're writing it, okay. Probability of a girl given that we predicted it's a girl. So our answer to question 1 is the probability it's a girl given that it's predicted to be a girl. So we'd find that probability, let's see, we're looking back at the table. Given that it's a girl, okay, that means that we're only going to consider those, given that it's predicted to be a girl. So which one's given, it's predicted, okay. Given that, so we're only going to look at those predicted to be a girl. We're only looking at the numbers in this row, because this is what was given. Given that it was, predicted to be a girl. Sorry about my messy handwriting. So like we said before, any conditional probabilities, you're just focusing on a certain row or a certain column, just whatever is the conditional part, whatever's given that. So we're only going to use numbers, two of those three numbers, okay. What are we trying to calculate? The probability of having a girl. So we want the number of girls in that row out of the total number. But like we said, we're only looking at that row that's highlighted up there. How many girls were actually born girls? It was 432 out of the total number there. Now we're not looking at the total number because we're not looking at just all babies all together. We're looking at only the ones that were predicted to be girls. So we're looking at the total of 562. And that, if you calculate that, dividing 432 by 562, you get 0.769. And that, like we said, this is a probability, so we're going to try to keep it that way. But if you move the decimal point over, it's 76.9. So 76.9% of those predicted to be female actually end up being female. So it's fairly reliable, but I wouldn't just go buy a bunch of pink stuff for your daughter. It might not, I don't know, that doesn't look like super sure probability there. And then the second question was, if the examination predicts a boy, how likely is it that the baby will be a boy? So it's kind of a similar thing. Let's kind of erase what we have here, because now it's another conditional probability, but now the condition is that it's predicted to be a boy. So now we're looking at the second row. We're only going to look at numbers in the second row now for this conditional. Given that it was predicted to be a boy. Okay, so we're only looking at that. I'm going to highlight this row. You might even just, if you're doing this calculation yourself, cover the other rows with your hands so you don't even look at them or something, or highlight it, yeah, whatever. So we're going to calculate that by saying what are the number of boys in that column that that were actually born boys out of the total number in that. Sorry, did I say column again? Row. The number of babies that were born boys in that row is here, because I see it above that number is boy. So 390 out of the total, which is 438. Okay. If I divide 390 by 438, I get 0.890. That's, you know, in percentages, that'd be 89.0%. So 89% of those that were predicted to be a boy actually were boys. And what did we say? It was 76.9% of those predicted to be girls actually were girls. So what conclusions can we draw? What kind of conclusions can we draw from this? If an ultrasound examination predicts a girl, the prediction is correct to about 75% of the time. But in contrast, when the prediction is a boy, it is correctly identified 89% of the time. Let's see. So now, let's comment here. Are you surprised at the answers to these questions? Looking just at the 3 given facts, you might have intuitively expected a different result. It did seem like that it was easier to identify girls than boys, because it said only 3 out of 4 babies that were predicted to be boys were actually boys, something like that, but it was 9 out of 10 for girls. This is exactly why a two-way table is so useful. It helps us organize the relevant information in a way that permits us to carry out a logical analysis. When it comes to probability, sometimes our intuitions need help.